Welcome to lecture in physics. We are going to consider the kinematical equations. Especially these kinematical equations are of three types: in linear motion, or you may say translational motion. And whether the same kinematical equations have analogy in circular motion or rotational motion, we have to discuss that part. We know very well that whenever the body is traveling along a straight line path, it is called as linear motion, with rectilinear motion, or simply translational motion. Whenever the same body is traveling along circular path, then it is called a circular motion. Or sometimes what happened, this body is rotating about himself, about its own axis, that is called a rotational motion. Whenever the body is traveling, let's say a man is running on the straight line path, a ball is moving along a straight line, or a car is moving along a straight road, then it possesses certain physical quantities. Initially its place is somewhere at point A, then after some time t, it appear at point B, at position B, at location B, and during this time t, its place changes by this much amount from A to B. This change in place is called as the displace or displacement. It is referred as linear displacement. Yes. Okay. Similarly, whenever the ball or the boy or the car is moving at two position, means from point A, from position A to position B, somehow like this, along this circular path in circular motion, then its radius vector, let's say r bar, is displaced, is changing its position, or translate, or you may say trace certain angle at center. This angle is called as angular displacement theta. What I mean to say, whenever you are talking about the displacement in linear motion, it is called as linear displacement, yes, and in translational, or sorry, circular motion, rotational motion, it is called as angular displacement theta. So these two physical quantities, in circular motion theta, in linear motion displacement is s. So this is how you can use the analogy between the physical quantities. At the same time, if the same boy, the same ball, or same car is moving with certain velocity, let's say its initial velocity is u, and its speed increases, its velocity increases up to b, from u to v, then this velocity change from u to v, initial velocity u, final velocity v, from a to b, during this time t, then we can say that the velocities in linear motion is referred as initial velocity u and final velocity v. Similarly, you have to consider here velocity as well. The velocity from A to B, and especially that velocity is called the angular velocity. It is represented by omega, and initial angular velocity is omega 1 and final angular velocity is omega 2. What I mean to say, the velocities in circular motion correspondingly represented as initial angular velocity is omega 1 and final angular velocity is omega 2. This is the analogy between these two physical quantities in linear motion and circular motion. Okay, let's talk about this acceleration. As the velocity is increasing from u to v, means the body gets accelerated, the speed of the car increases, the speed of the man or speed of the ball increases, then we can say that it's possess certain acceleration, that is called the linear acceleration a here. At the same time, here also the speed of this man along this circular track increases in terms of angular speed omega 1 to omega 2, or angular speed of car or angular speed of this ball moving along this circular track increases from omega 1 to omega 2. Even here also it possesses acceleration, that is none other than angular acceleration alpha. So you have to use analogy. Linear acceleration in linear motion is analogous to angular acceleration alpha in circular motion. So these physical quantities we have to consider while considering the kinematical equations, and there are different kinematical equation in terms of this physical quantity along with the time as well. Similarly, physical quantities analogous is in circular motion. We have to prepare this kinematical equation for this circular motion as well. So which are those kinematical equations? Let me remind you. You know very well that the first kinematical equation in linear motion is v equal to u plus a into t. where v is final velocity, u is initial velocity, acceleration and time. Similar kinematical equation is there for this circular motion also. So the first kinematical equation in case of circular motion is final velocity v here final angular velocity is omega 2 equal to initial angular velocity is initial linear velocity is u here, initial angular velocity should be omega 1 here, then plus a is linear acceleration, alpha is angular acceleration, then time factor same here as well. So this is the first kinematical equation in case of circular motion or rotational motion, similar to kinematical equation in linear motion. Do you remember the second kinematical equation in linear motion is about the displacement s, initial velocity u and acceleration a. What is that? Let me write that. S is equal to u initial velocity into time t plus half a acceleration, linear acceleration into t square, time square. The same expression can be written here as well, second kinematical equation. The second kinematical equation for the circular motion is displacement is yes here displacement is theta equal to here initial velocity is u into t, here initial angular velocity is omega 1 into t plus as it is plus half as it is, linear acceleration a, here angular acceleration is alpha into t square, here also t square. So these are the two kinematical equation in circular motion, corresponding kinematical equation in linear motion. We are using analogy between these two equations. The last one, the last kinematical equation in linear motion is, if you are remembering that, v square, final velocity square, equal to u square, initial velocity square, plus twice a, linear acceleration, into s, linear displacement. The same kinematical equation for this circular motion can be written in this way. Third one, final velocity square, here final velocity is omega 2 square is equal to initial velocity square, here initial angular velocity is omega 1 along with the square, plus 2 as it is, linear acceleration is a, here angular acceleration is alpha, into linear displacement is yes, here angular displacement is theta. So this will be my third kinematical equation in circular motion, which is exactly analogous to third kinematical equation in linear motion. So this is how you can prepare the kinematical equation in circular motion by using the analogy with kinematical equation in linear motion. All these equations are quite essential as per considered to the examination point of view or any theoretical basis for upcoming theory. I hope you understood. See you next time.